Hey everybody, this is Larry. This is day 22 of the September Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. I'm still in San Sebastian, but I'm about to leave because I'm going to I need to check out to my hotel and so this may be a little bit shorter than usual. But yeah, let's see what the problem is and figure it out. And yeah, keep in mind I usually solve these live, so if it's a little bit slow, just watch it on a faster speed. If it's a little bit fast, watch it on a slower speed. I don't know. Do whatever you need to do. Today's problem is maximum length of a concatenated string with unique characters. We're in the fourth week. Yay! Way to go if you're here. But let's get started. Okay, given an array string S is a concatenation of substring that is unique characters. Subsequence of R. Okay, all of them. Possible concatenations. Okay, I see. Okay, I guess the key thing is noticing that n is 16 because that's usually because basically the thing that I maybe do is that I ask myself what is the laziest or what is the most most naive thing that I can get away with, right? And given here, um, the concatenation don't even matter because the thing that matters is the unique sequence because unique character because as long as they have a unique character, it doesn't matter what order things are in. So, but yeah, when I look at n is equal to 16, then I go, okay, that means that 2 to the 16 is possible, right? And here, when you see subsequence, um, it means that you can every possibility, every subsequence. There's only 2 to the 16 subsequence. So in that case, we can do something that's roughly n times 2 to the n, and that should be fast enough. It's 2 to the 16, if you do your math mentally, I did not. What's 2 to the 10? 2 to the 10 is 1,000, so 2 to the 16 is me plugging into a calculator, so I don't know, embarrassing. No, I mean, it's like 60,000, right? So 65,000, I think. Let me plug it in. Okay. It's either 65,000, 32,000. Sometimes I mess up. But just kidding. But yeah. So 65,000 times 16, which is no, another 2 to the 3, right? Well, no, 16 is 2 to the 4. So that means that 2 to the 16 times 2 to the 4, which is 2 to the 20, which is a million. So that's going to be way fast enough. Of course, you have to times that by maybe 26, depending on how you do it. So it's like 26 million because that's the number of lowercase English letters, right? You can do your math in another way, but these are the things that convince me that okay, it's okay to do the brute force way, and then I'm gonna get started. There are a couple of ways you can do this brute force. Um, yeah, and some of this will require. I was going to do, to be honest, something that is innate to me and something that I've been doing a long time is using bitmask. But maybe for some reason, because I think I just got used to it, but maybe this is time for me to yeah, to not use bitmask and do recursive. Maybe that's a challenge for me. I'm also thinking about using either, well, there's two things to do bitmask. One is the iteration of the permutation or the subsequences, but the other is to just emanate a set of 26 items, which I may not do. Don't know if it's necessary. We'll see if it's. I think I might need to because that's optimization that I don't know. It does make it 26 times faster instead of using a set or something for every character. So, I'm gonna do that. I I think usually I would spend some time to go over bit masks in general, especially since this is on a daily challenge. I try to be more educational, but today, like I said, I'm getting kicked out of my room pretty soon. I have to check out, so I apologize for that. If you need a bit mask tutorial, definitely go to my Discord, or I have a tutorial, but I always forget what the link is. But hopefully someone will post it below as well, or ask me in the questions below. Anyway, so yeah, but just to give like a 2-minute tutorial, big mask is just a big mask is just basically having a vector of booleans, because you can think about, you know, each number as kind of some binary representation of that number, and then here it's just we're checking whether that digit is 1 or 0, 1 being true or 0 equal false. I guess you could swap it if you want, but that's the general convention. That's basically it. You check whether each bit is 1 or 0, and that's all bit mask is. It's just a vector or a list of Boolean values. I mean, the actual looking at the syntax looks kind of messy, but yeah. Okay, so let's do this recursively. So yeah, let's go the index that we're working on and the current bit mask, right? If index is equal to n, where n is, so we basically parse all the way, then the maximum possible length. Well, the maximum possible length is just the length of the bit mask, right? Because in this case, and you could put it in a recursion thing as well, so we could do it both ways. It doesn't really matter. If you ask me a bit. Know that I'm going to add a parameter here just for me, easier for me to do, but know that doesn't really matter, because implicit in the score is in the bit mask, right? But basically, the score is just the number of true values that are in mask. Okay, and then now just to parse, and then now we have two possibilities for each index, which is we add this index, or we don't add it, right? So then here, if we add it, we just index plus 1, mask, we, or let's just say m of index. We'll have to calculate that. I didn't think it close enough. Score plus, let's just say score of index. We'll quickly calculate that as well. We also have to do a check, of course. Not adding is easy, so we just do this because nothing had changed, right? Maybe statistically it even looks better here, this way. But here, of course, you have to do mask, and m of index is equal to 0. That means that there's no intersection, and you do this. And then that's pretty much it for this one. We have to do some other stuff. And let me kick it off. Yeah, and then now we have to basically pre-calculate the mask. And like I said, it's just a set of Boolean values, right? So then now we can do for what do I call it? Let's just say S for string, you know. Or I think I want to use S somewhere for score because I'm really bad today. Let's just say for naming stuff is hard. What's it called? Let's just take element. E for element. I'm terrible. Sorry, friends. Get out soon. And also, my internet is very slow, so it may take time to upload anyway. I don't even know if this will get up on time. But anyway, let's see. Yeah, so we have mask is equal to and S is equal to and for each element, and then for I in range of 26. Oh, maybe we don't need to do that way. Well, S of enumerate, but I guess we got this whatever. S of I is equal just to length of the array. Length of V, because we assume that actually I said that we assume that each thing inside will be unique, but maybe I'm wrong on that one. I actually had assumed that Let's try it. I don't know if this is a valid thing. So let's try. Is this a valid input? It seems like it would be, but oh. Hmm. Okay, so it is a valid input, so that's good. Um, hmm, that's a little bit sad actually. But so then here, hmm, hmm. Yeah, let's actually set it up then. Then characters is equal to 0, let's just say, or count is equal to 0, doesn't really matter. So now for x and v, we do something like now we've converted from basically the character to from 0 to 25. So basically, this is the offset, maybe say, and then we m sub I. Oops, we flip off that bit, but only if it isn't already done. So if m sub I and if this is greater than 0, so that means that the bit is already flipped or already true, then we do something really funky. Let's just set this to some negative infinity, right? Otherwise, we increment it by 1, and should be okay. We'll just give it some big negative number, and infinity, we just set it to some big number anyway. I know that you could do the full version, but sometimes you do arithmetic on it, it gets messy. Okay, so now that looks good. And I think we're done, really, to be honest. Let's see, might as well copy and paste the other answer. The fact that they made this length of each thing is 26 fooled me a little bit on the duplicate letters, but yeah, we're good. Um, yeah, I mean, you can imagine using set instead for m sub I, or even just array of Boolean values. I think that should be okay. Actually, I think now, to be honest, I think using a list of Boolean values and set is probably okay. Maybe I overspoke how much of an optimization this is, but the reason is because this thing would be all of this could take 26 instead of all. This is always all of one. Oh, sorry. I mean, it is always all of one regardless, even if you use an array. But this would be one operation ish here. But if you use a set or something like that, it could be up to 26 operations because you have to do a set intersection of every character. So that's why I did it. I don't know. Let me know if you did it the other way, and let me know if it's fast enough. But yeah, uh, so we go through each. I think we already went through the complexity, right? Which is that for each index we branch up to twice. So that means that this is going to be O of 2 to the n. Like I said, technically this is O of n because this or something like that. So O of alpha, I suppose, where alpha is let's pretend that's an alpha. The length of the size of the alphabet in this case is 26. So yeah, and of course you can add this to just like O of n stuff here, or n times a. So yeah, I think I was wrong earlier when I said it was n times 2 to the n, but I think that's just how I would do it because in general it's usually, to be honest, n times 2 to the n. Like it comes up a lot, n times 2 to the n. And I think it would have been 2 to the n if we didn't want to score here because we already pre-processed it. That's why it's not 2 to the n. Because normally you would do a for loop here, and that would be, well, actually, that would be 2 to the, that would be another factor of n. But I don't know. I mean, I think for me, it's just that n times 2 to the n is a good gauge to know whether it's fast enough for a brute force to run. Because it is very often n times 2 to the n, but not this time, I suppose. In terms of space, this is linear because we just have two arrays, and and stack space, I suppose, but that can only be O of n. So yeah, yeah. That's all I have for this one. Let me know what you think. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think. Have a good day, have a great whatever. I'll see you later. To good mental health. Bye bye.